by losing that oxygen. And suppose there is a molecule which is giving us oxygen atoms freely, we should be glad about that. Suppose there is a molecule which is giving oxygen atoms kill bacteria. We live with oxygen, bacteria dies of oxygen, I don't know how. Bacteria is killed by nascent oxygen. Therefore, H2O2 can be used as an antiseptic, a water purifier. You heard about ozonized drinking water, haven't you? Ozonized drinking water. So, what does ozone do? Ozone gives an oxygen atom which in turn kills bacteria. Water purifier, antiseptic. And whenever there is an oxygen atom, that oxygen atom will act as a bleaching agent. Therefore, all these less stable molecules, H2O2, H2O, O3, ozone wants to become O2, wants to become less stable, wants to become, the emphasis on, wants to become, if possible, slight heating. I am not talking about terrible heating, slight heating, only slight heating, CaOCl2, the so-called bleaching powder, wants to become CaCl2. HClO, hypochlorous acid, wants to become HCl. Sodium hypochlorite, NaClO, wants to become NaCl. What is that you observe? All these compounds have one oxygen atom extra. All peroxy substances, they want to become oxy substances. So, if you find any one of them, they all will give you an oxygen atom, and that oxygen atom can be used for, so they are all oxidizing agents. So, they all produce a nascent oxygen, plus O, oxygen atom, plus O, plus O, plus O. So, less stable, they all have one extra oxygen. One oxygen atom extra, one oxygen atom more than their comfort. Therefore, they easily give us oxygen atoms, and we can use the oxygen atom whichever way we like. If you want that oxygen to be added to someone else, you can do that gladly. I will give you examples. Since we are discussing elements of 6A, I will stick to elements of 6A. Suppose, how does Na2SO3 react with ozone? What will be the products? What do you know about ozone? O3. It gives an oxygen. So, ozone throws an oxygen. Who will take that? Here you have Na plus, SO3 2 minus. What exactly is SO3 2 minus? 1 sulfur, 3 oxygens, 2 of them are minus. Oxygen forms 2 bonds and sulfur has a lone pair. So, when it gets an oxygen, it gladly combines with the oxygen because sulfite wants to become sulfate to get rid of that lone pair, pyramidal to tetrahedral. Therefore, when it is combined with ozone, Na plus is a spectator. So, Li plus, Na plus, K plus, wherever they are spectators. They have no role to play in any reaction. Spectators. Li plus, Na plus, K plus, they are spectators. They play no role in any reaction. So, Na2SO3 sodium sulfite means only sulfite. Forget sodiums. They don't have any role. So, sulfite becomes sulfate, SO4 2 minus. Why? Double bond O, O minus, O minus. So, what is the conclusion here? This is pyramidal, that is tetrahedral. Pyramidal to tetrahedral. So, what are the products? You say Na2SO4 plus O2. So, you just find this reaction in books without much explanation. Books don't explain completely. So, Na2SO3 plus O3, why do you get Na2SO4? Here ozone has a reason to lose oxygen and sulfide has a reason to take oxygen. He doesn't want an oxygen and he wants an oxygen. Why does he want an oxygen? To get rid of the lone pair. to keep all electrons busy. Here you have a lone pair of electrons which is repelling the bond pairs. So most of the time lone pair should be avoided as far as possible, whether it is through a reaction or whether through adjusting the structure. Lone pair should be avoided. So these are the only reactions of ozone. This way only we treat all reactions of ozone. Nitrites want to become nitrates, sulfites want to become sulfate, only to get rid of lone pairs. KNO2 plus O3. How to understand? How to predict the products? You break K plus spectator, he doesn't do anything, he has no role to play. And you have NO2 minus. What about NO2 minus? K plus is a spectator, forget about him. No role to play, not in this reaction, for that matter, any reaction. NO2 minus, N, one nitrogen, two oxygens, one of them is a minus, double bond, single bond, and nitrogen has a lone pair. And therefore, nitrite wants to become nitrate. So you get KNO3 plus O2. So here ozone gives an oxygen that is absorbed by NO2 minus, that is actually reacting with NO2 minus, allowing you to get nitrite become nitrate, bent becomes planar, bent planar. Lone pair is avoided. Look here, N double bond O minus, and this lone pair is being donated to oxygen. So wherever you have ozone or H2O2 or bleaching powder for that matter, their reactivity is just leaving oxygens. How does H2O2 react with ozone? You have to explain the products with reason. H2O2 has got a peroxy bond, oxygen similar bond. H2O2 wants to become H2O. O3 wants to become O2. H2O2 wants to become H2O. Ozone wants to become O2. So this fellow is throwing one oxygen atom, and this fellow is also throwing one oxygen atom. These two will combine, end up giving plus one more O2. So H2O2 throws one oxygen, ozone throws another oxygen. The two oxygens will become O2. So H2O2 becomes H2O, ozone becomes O2. So H2O plus 2O2, that is how the reactivity goes. NH3 plus CaOCl2. Predict the products. What did we say about CaOCl2? It is CaCl2, it wants to become CaCl2. On slight heating, mind you, we never discuss reactions involving high amount of heat. Slight heating, this oxygen will come out. And who will that oxygen react with? All oxygens want to become H2O. All oxygens want to become H2O because H2O is the most stable molecule. Evidence? 3/4 of the earth is covered with water. If water were not stable, it would have decomposed to give H2O. You would have got hydrogen atoms and oxygen atoms. But this reaction doesn't take place at all. Even at a high temperature, 300, 400, 600 also, H2O remains H2O. The bond is not broken easily. H2O is a very stable molecule. All oxygens one day want to become H2O if possible. If possible is the principle, if possible. And H2O being a very, why is it very stable? OH bond is very strong. Evidence, 3/4 of the earth is covered with water. And so oxygen on slight heating. And all nitrogens want to become N2. All nitrogen atoms want to become N2. These two are the basic principles of most of the chemical reactions. I repeat, these two are very, very important, ultimately important. All oxygens want to become H2O. All nitrogen atoms want to become N2. So what is it here? Here is an oxygen atom, here are hydrogens, you get H2O as planned. All nitrogens want to become N2. Don't worry about balancing this reaction. You write 2NH3, 2NH3. You have 6 hydrogens, 3 H2O, for which you may have to take 3 CaOCl2. You get 3 CaCl2. So you have N2, 2 nitrogens N2, 6 hydrogens which will become 3 H2O, for which you need 3 oxygen atoms. you take 3 bleaching powder, CaOCl2 is bleaching powder. So this reaction exemplifies so many things. This reaction, CaOCl2, the oxygen is an extra oxygen, a weakly bonded oxygen. What about HClO, HOCl? Here you have 2 lone pairs and 3 lone pairs. Tremendous repulsion between 2, 3 lone pairs, bond is weak. Therefore, ClO bond is very weak, ClO bond. I told you OO bond itself is very weak. OO bond itself is very weak. Therefore, this reaction exemplifies so many things. All nitrogens want to become N2, all oxygens want to become H2O. So that is it. That is what we studied is reactivity. So what we have to learn are not reactions but reactivity as a whole. We should study reactivity, not reactions.
Dear students, ఈ రోజు ఎపిసోడ్లో కెమిస్ట్రీ గ్రూప్స్లో 6th A అంశాలకు సంబంధించి తెలుసుకున్నాం కదా. మరి నెక్స్ట్ ఎపిసోడ్లో మరో కీలక అంశానికి సంబంధించిన లెసన్స్ చూద్దాం. ఈ కార్యక్రమంపై మీ సందేహాలను, సలహాలను మరియు మీ అభిప్రాయాలను eclasses@kabtv.net కు పంపించండి. Till then, keep watching KAB television.